Hey, so I'm just creating this slide deck on tools for reproducibility in statistics and machine learning for summer school, and I thought this might be interesting to a wider audience, so I decided to do a screencast about it. My name is Heidi Seibold, and on Twitter I'm at Heidi Bayer. The slides are available online, and you can reuse them if you like. Who am I? I work as a postdoc at the University of Munich. There I am the head of the analysis group of the Data Integration Center. I am also an assistant editor for the Journal of Statistical Software, where I do reproducibility checks and copy editing. I'm a member of the LMU Open Science Center and a core member of OpenML. So I'm involved in a couple of open science projects and things that deal with reproducibility. And I also like to teach about these topics. So this presentation is quite personal. So it's all the tools that I use in my daily work. So this might not be the same for you, and I don't recommend that everyone has to use the same tools. It's just the tools that I like, and maybe this is useful for you as well. Why do I talk about reproducibility if I'm interested in open science? I think that to have open science, we need altruistic scientists, scientists who are willing to share their work with the world without wanting much back. So I think what we need is more altruistic scientists to get open science. For reproducible science, I think we need extremely well-organized scientists. So getting computational reproducibility is hard, and you need to be quite organized and have a good tool set to be able to have reproducibility. How do these two things fit together? I think we will only then be comfortable working open if we're confident about the reproducibility of our work. Because if we think that our work is not good, then we might not want to show this to other people or to the world. So I think reproducibility comes as a step before openness. Or also, if we're open without being reproducible, then that just means it's not very useful to be open, because then the work is maybe not as good. I'm talking here about computational reproducibility. I think it's a little bit more complicated when we talk about entire studies. So this presentation is about the tools that I use, and I want to show this based on a project that I'm working on currently. I'm going to talk about a couple of more tools later that I also use, but the tools that I use here are like at the core of every project that I do. So I have this project where we want to figure out for MS patients which is the best treatment for which type of patient. And for this, we use retrospective data from clinical practice. So the patients come into the hospital, they get diagnosed, they get tests, they have treatments, and this data is collected within the hospital. And we want to use this now to figure out if there's maybe any signs that some treatments work better for some types of patients than for others. I think that this project will go in 4 steps from my side. The first step will be data preparation, then analysis preparation, analysis, and then presentation. For all of these 4 steps, I use as tools, first of all, R, which I need to clean the data, to analyze the data, and also to visualize the data. Then I use version control. For this, I use Git, and the university also has a GitLab server where I store all the code and version control all the code. Then I use Make. Make is a tool for automizing all of the steps. So in the end, I can just say make all, and then I'm sure that this whole pipeline from data preparation to presentation runs through smoothly without any problems. And I can specify and make which documents depend on other documents, so which R script depends on which R script, and then the paper obviously depends on all the previous things, for example. Then I haven't set this up yet, but this is something that I want to do, a virtual machine. This I use to have a stable environment in which I compute all the things that doesn't change. So if I do this on my laptop, then I will always install new stuff, update my R packages, upgrade my computer, things like that. And then the problem is that maybe due to a change in an R package, the results will differ suddenly. And this means my results are not reproducible anymore. So that's why I use a virtual machine for each project. So every project gets its own virtual machine to keep the computing environment stable. You can also maybe use Docker for this, but I've had better experiences using virtual machines. Okay, so in the first step of data preparation, I need to talk a lot to the clinicians to discuss how do we select the patients and how do we define our data set. So for this, I use our Markdown, so there I can do a bit of data cleaning, a bit of data visualization, and export everything into a Word file, which I can then show to the doctors where they can make comments, and we can discuss how to move forward. In the analysis preparation part, I write an analysis protocol, which I will use knitr for. So knitr is a combination of R and LaTeX. And then I produce a PDF with the analysis protocol. So this defines how will I do the analysis and what models will I use, what data will I use. And then I can put this on the Open Science framework so that later people can go back and see if I actually did what I planned on doing, and that I can show, this was a planned analysis, and this seems like it's best practice in this case. So I've never used the Open Science framework before, but I think it's very useful for pre-registering studies. And since the data is retrospective, we didn't pre-register the study itself, but I definitely want to pre-register the analysis protocol. So, and then in the next step of the analysis, I use R. I need to be very organized and rerun things often a couple of times. Sometimes I do simulation studies. So I will have a couple of R files that I run and need to keep version controlled and keep automized using Make. And then in the final step, presentation, I will obviously write a paper, or if we get that far, no, that's, so I will write a paper. For this, I will use knitr again. I always write my papers using knitr because then I can export them into a LaTeX file, and the journals that I submit to usually accept that. And in this way, I don't have to copy paste images and tables and stuff. So I can all create that using knitr. And then I can publish the preprint on arXiv, or maybe since I also plan on pre-registering the analysis report on the Open Science framework. I will probably also publish a preprint on the Open Science framework, but probably also on arXiv, because this is where I usually put my preprints. And then I will most likely go to a couple of conferences where I present my work. The slides I also create using Knitter, and submit. Then I, of course, also submit the paper to a journal. And then we'll go on and have a follow-up project where we will try and validate the model that we created during this project using new patient data that we're in the process of collecting now. So these tools are like the tools that I want to use for this particular project. But there's obviously a couple of other tools that I haven't mentioned for this project. And these are, I think, most of the tools that I use. I didn't add editors to this. So as editors, I use RStudio and Vim mostly. But let's go through all these tools. I try to group them into categories. They're not optimal, but I needed to structure them somehow. So let's start with organization. I think organization is very important. I organize my work life using GitLab issues. So GitLab is this online platform that's like GitHub. I like GitLab a bit better, and the university has its own GitLab server, so I'm not dependent on a company. And I have one repository where essentially don't have any files, but only issues that I use for organizing my to-dos. Then for organization, I think it's also good to have a good folder structure, to name your folders in a smart way so you can find everything again. For a project, I will usually have the main folder that's called like the project, and then I have subfolders that are called raw data, clean data, analysis, simulation, where I store things accordingly. And in the main file, I will usually have the manuscript. Then let's move on to version control. In version control, I obviously have Git and Subversion. So I use Git for most of my projects. I use Subversion for R packages because we have our R packages on RForge. Then to the category of version control, I also added online text editing because not everyone knows how to use Git and SVN. And if I have collaborations where I work with people who don't have Git or SVN, then I will sometimes use other tools. Like, for example, Overleaf allows you to do version control automatically. And it's very easy for people who don't usually use version control. It's very easy for them to use, and it's very straightforward without them having to learn Git or SVN. I also added virtual machines and Docker to this version control group because it's not really version control. It's more like keeping my environment stable. But I felt it's best under version control. Then automation, there I have terminal and bash. I work in Linux because I obviously also like open source and not only open science. So I use terminal a lot. I use make. I talked about make already before. As a statistician, R is maybe the most important tool for me. And then I see also Knitter and R Markdown in this automation category because it just helps me automate writing documents. And I think it's much better than, for example, using Word. Then in the documentation category, I'll again have knitr in R Markdown because I can also use it for documenting the steps that I take in an analysis. And I also added LaTeX as a tool for writing text. For documenting functions in R, I use Roxygen. I use it for writing packages, but also when I use just functions for a project, because I'm just so used to documenting my functions using Roxygen. And it's just so nice to go back to a 5-year-old project and still understand what the function is used for. And I also added naming here. It's not really a tool, but I feel like it's so important that I wanted to add this. So use good names for folders, for files, for functions, for objects in R. So naming is important, I think. And then finally, publishing. There's a couple of things. GitLab I use for publishing my code. But for example, I also publish my slides on GitLab if I create them using knitr or LaTeX. Then I have a couple of online presences. So I have a work website, I have a Twitter account, I have a blog that I'm not very active on currently. I think this is quite important to have an online presence as a researcher nowadays. Then I already discussed the Open Science Framework. I think this is a quite useful tool to pre-register, but also to make your code available in combination with all the other research outputs. So the Open Science Framework essentially, I think, takes all kinds of research outputs in an organized way, and you can just have a project, and in that project you put all the research output that you create. There it's also obviously very important to document what is what and make sure that people can also understand what you put there. Then OpenML is a very machine learning focused platform where you can store data, questions about the data, so machine learning questions, prediction questions, in combination with code, not really code, algorithms. And for example, this is very useful for machine learners if they want to do a benchmark study or something. I recommend using OpenML very much. And then, of course, we use preprints to make our work available as soon as possible in a paper format, but we also publish in journals. So these are essentially the tools that I use. And I hope this was helpful to you. Now I want to finish with a little bit of advertisement because we have a couple of open positions in the Data Integration Center. We're looking for mostly computer scientists, but also for the coordination group. So if you're interested in medicine, in computer science, in working in a medical informatics project, then this might be interesting to you. And if you're interested, just email us and we'll see. Maybe we'll work together someday.